A cyclist starts 20 km west of an intersection. So let's say that the cyclist start from here, which is 20 kilometers of an intersection. So that will be 20 kilometers. And then as the time passes, the bike is getting closer and closer to the intersection. So let's call x to be the distance, to be precise, x of t to be the distance at time t, the distance from the bike to the intersection. Okay, to be precise, this should be x of t, x a function of t. But let's write just x, but keep in mind that this x is a function of t. Okay, and the distance from the intersection, so a cappuccino bar is located 5 kilometers south of the intersection at the point C. At what rate is the distance between the cyclists? So let's say that the distance between the bike and the bar is y here. Okay. At what rate is the distance between the cyclist and the cappuccino bar decreasing when the cyclist is halfway to the intersection? Okay, let's translate the problem into mathematical notation. So first we know that the bike has constant speed of 40 kilometers per hour. Okay. So we translate this into the rate of x, which is equal to negative 40 kilometers per hour. Why is this negative? Okay, so x is measuring the distance between the bike and the intersection. As the time passes, the distance between the bike and the intersection point is getting shorter. So that tells us that the rate must be negative because x is decreasing. So that is the given information. And what we are looking for here, we want to find the rate of y. At a particular time, when the bike is halfway to the intersection from the starting point. So half of 20 kilometer is 10 kilometer. So we want to find dy over dt when the distance between the bike and the intersection is 10, which is half of 20 kilometer. Okay, so now we want to find the relationship between the rates of x and the rates of y. In order to be able to find the relationship between these two rates, first we need to find an equation that relates x and y. And in this case, because we have a right triangle, we have x squared plus 5 squared equals y squared. And then we can take the derivative with respect to t, 2x dx over dt is equal to 2y dy over dt. Okay, let's check if we have all the information we have to solve for dy over dt. To solve for dy over dt, we need x, we know x, we need dx over dt, we know that, but we don't know yet y. So first we need to find the y value when x is 10. So we say that when x is 10, we have the following diagram. The same triangle like above. The distance between the intersection and the cafe is still 5. Okay, and here when x equals 10, and we have y. So again, by using Pythagorean theorem, we have that y squared is 10 squared plus 5 squared, which is 125. Thus, y is equal to the positive solution to this. So square root of 125, which is 5 times square root of 5. Okay, now we have all the information to solve for dy over dt. So plug into that equation, plug into 1, we have 2x, 2 times 10, dx over dt. dx over dt is given, negative 40 km per hour, equals 2 times y. So y is 5 square root of 5, dy over dt. We can simplify a little bit, cancel the 2. Solving for dy over dt, we have 10 times negative 40 divided by 5 square root of 5. 10 over 5 is 2, so negative 80 over square root of 5. Now we can rationalize the denominator by multiplying the top and the bottom by square root of 5. So this is equivalent to negative 80 square root of 5 over 5, which is equal to negative 16 times square root of 5. And don't forget the unit. The unit is in kilometer per hour. And that's all. Thank you for your kind attention.